So, today, mag-start na tag lesson sa thermodynamics. So first, we have the course description of thermodynamics. It is a course dealing with the thermodynamic properties of pure substances, ideal and real gases, and the study and application of the laws of thermodynamics. In the analysis of processes and cycles, it includes introduction to vapor and gas cycles. So we have two thermodynamic subjects, thermodynamics 1 and thermodynamics 2. So mas broad ang thermodynamics 2, that's why we need to understand first ang thermodynamics 1. So after completing this course, the student must be able to identify the different properties of pure substance, ideal gas, and real gas. Apply thermodynamic concepts and principles in analyzing and solving problems. Apply the laws of thermodynamics in analyzing problems. Evaluate the performance of thermodynamic cycles. So we have the course outline. So we have introduction, basic principles, concept, and definition, which is our topic for today. The first law of thermodynamics, ideal gases or ideal gas laws, processes of ideal gases, properties of pure substance, processes of pure substance, introduction to cycle analysis, or the second law of thermodynamics, introduction to gas and vapor cycles, and then real gases. So now, let's go to thermodynamics. So today we are going to tackle about the basic concepts, definitions, and principles of thermodynamics. So before that, let's have a general overview. So since we are taking up mechanical engineering, let us understand kung unsa ang ay okay lang ba mag na Bisaya? Makaintindi ba ta ng Bisaya? At least mas ma-explain na ko og maayo, no? Okay. So we have we are studying now mechanical engineering, and then let us understand the relationship of thermodynamics and mechanical engineering. So we have four components of mechanical engineering. We have mechanics, energy systems, and design. So under sa energy, we have thermodynamics. So it is a component of energy ang thermodynamics. Why? So first, thermodynamics, wait lang. So, there is ata sa mechanical engineering. So, we know that mechanical engineering is a branch of engineering that focuses on mechanical systems, mechanical devices. And then we analyze, we create those such devices to, of course, we have the common goal of every engineering. It is to improve the quality life of human. So, the overarching goal is design of products to meet societal needs. So, in mechanical engineering, we improve the quality of life pinaagi sa paghimo og mga mechanical systems, mechanical devices. And one of that for us to make designs and different mechanical systems, we need to understand about thermodynamics. Why? Because it is one of the foundation of mechanical engineering. Thermodynamics is a science of energy. So from the Greek words therm means heat, and then dynamis means power. So we can understand that uh, that time na nag-start ang thermodynamics mga 1600s, thermodynamics, they use heat to produce power, or they use heat to produce power. So it governs all energy and consuming and transforming devices and system. And also, we have kung ma-recall nato ang ato ang elementary days, we know about the law of conservation of energy, which states that energy cannot be created nor destroyed, but can only be transformed from one energy to another. So also, when nag-transform ang energy from one form to another, the total amount of energy remains constant. So for example, um, anyway, before that, we know that law of thermodynamics, sorry, ang law of conservation of energy is the first law of ter- uh, is the first law of thermodynamics. So for example, um, ano, example na ay isa ka bato na mahulog sa isa ka cliff and it has a potential energy of 10 10 units. So let's say 10 units ang potential energy, so ang kinetic energy niya is 0. But at the time na ma-fall na ang bato, the potential energy becomes 7, let's say 7 units, then what will happen to the rest of 3 units? So it will become kinetic energy. So kung i-total na to ang iyahang total amount of energy, 10 units gihapon siya. So wala siya nag-differ because as the law states, the total amount of energy remains constant. Ano lang to siya, background. So now, let us go to the engineering framework. We have the engineering framework, theory, data, and judgment. So just like sa research framework, ang sa engineering naman, we have the theory. Sa theory or the problem, so we have the theory. One of the there are so many theories sa engineering, and one of those is ang thermodynamics. So we have thermodynamics, we have fluid mechanics, tanan-tanan na atong ginatun-an kay part na siya sa theory. And then we have kapag naana tayo theories, we find problems to solve. Then after that, we gather the data, and after we gather the data, we propose solutions to those problems in mechanical forms, in mechanical devices. So after that, we have the judgment or the validation of the design kutong naisip nato na solution for that problem. And then after that, just like sa research, na nag-start sa problem, it will end also sa problem. So we know that wala nag-stuck in one end ang isa ka device. Naa siya mga improvements. So wala siyang cycle. Anyways, ano lang to siya ng agi lang ta. So now we have the application areas of thermodynamics. So since we are mechanical engineering, kinahanglan nato sabton pud ang application areas. We have the human body, we have the air conditioning systems, ang heating and cooling, we have the refrigeration systems, we have the airplanes, we have the power plants, and we have the car radiators or ang mga sa automotives. So kinsa pa ang nagahimo ani na mga kind of systems ang mga mechanical engineers. Then kung atong sabton sa kung atong sabton tanan ni sila na naga-involve og thermodynamics. Okay? So also uh, ang universe is governed by the law of thermodynamics because just like I said ganina, thermodynamics is a science of energy and everything around us that surrounds us kay energy. So kung paspas kayo ko ha ayaw lang jud og hesitate na mag-ingon kung paspas kayo ko. So now thermodynamics is like any other math, calculus, physics, and other maths na naatay mga problem solving. So sa problem solving we have units. Of course, kinahanglan jud ng units and physical science ang thermodynamics. So sa thermodynamics, we should check for the dimensional homogeneity. So what is dimensional homogeneity? It is an expression where or dili expression. Um Ang dimensional homogeneity is that the equation must have or the terms in an equation must have the same units. So we have two different kinds of measuring system. We have the SI system or the international system or the standard international system which uses ang metric system. So we have kilogram, we have meters, we have seconds, we have Newton. And then we have the English system which is ginagamit tong pounds, yards, feet, naagya po yung seconds. So, we need to learn about conversion of these units kasi ingon daw ni Sir sa mga problems in the future sa thermodynamics, we will be encountering English units, example pound mass. Pero ang ginapangita is Newton. Napod na ang ginapangita is ang gihatag is kilograms or Newton, then if convert into pound force. So kinahanglan na siya sa dihan. Naa na siya sa ano sa Kengel and Bowles na reference book. Pwede niyo siya dito masahan more further. So kung bali mag-dissect lang ko ani og part na about sa conversion, mag-post lang ko og another video sa about sa conversion of metric system to English system or vice versa. Dali lang man siya guys ang conversion, dili man siya nga ato ka kalisod. Convert lang man. So mo na siya. So dapat same ang unit. So sa isa ka problem kung Newton, dapat Newton ang mogawas, dili pound force ano. So we have the beginning ideas and concepts for thermodynamics. And in studying thermodynamics, we have two kinds of approaches. We have the macroscopic approach and the microscopic approach. Or ang ginatawag po sa macroscopic approach is classical thermodynamics and ang ginatawag po sa microscopic kay statistical thermodynamics. So what is macroscopic approach? Macroscopic approach is the study of thermodynamics concerning the actual or the overall behavior of the system. So, ang system is a quantity of matter or region in space chosen for study. So mao na siya ang subject sa ato ang study. Usually ang system kay mga gases usually. But anything can be a system. So pwede ako maging system ko isa ka tao, pwede po maging system isa ka computer or isa ka matter. So depende kung unsa atong gina-focus sa study or sa isa ka problem chosen na subject sa isa ka problem. So, ang macroscopic system ang overall. Then, ang microscopic, it is the study of thermodynamics in molecular level or atomic level. It means the average or the average behavior of the atoms or the molecules inside the system. So, just like example ani, ang ginasadihan is ang unique velocity. Unique velocity sa atoms, ang distance sa sulod, kung pila ka buok number sa atoms, kung unsa yang total energy, mao na siya sa microscopic. For example kani, energy in microscopic description. We have the energy per each atom, we have the number of atoms, we have the total energy. Kung macroscopic ta, ang macroscopic is ang ato ang pangitaon na energy is not the energy of each atom but the total energy of the system itself. And also dagdag sa macroscopic approach, sa macroscopic approach di mas dali para sa tuan na mag-solve sa problem kung naanay given na temperature as a whole system, na atay temperature gauge, na atay mga pressure gauge. So mao na siyang sa macroscopic description. Ang macroscopic description is for thermodynamics sa mechanical engineering. Ang microscopic usually ginagamit na siya sa chemical engineering. So kita sa mechanical engineering, mas gamit na to ang macroscopic approach. Dili ang microscopic, bali supporting role lang na siya. Then okay lang nasabtan ang macroscopic and microscopic no. So macroscopic description, we have example, the energy in both cases is the same E or energy or internal energy. In the macroscopic description, atomistic concepts are disregarded. How we describe the system, how we describe the system chosen for study requires a careful selection of properties. So unsa ni siya ng properties that are based on observable and measurable quantities. So ma-measure lang siya by the naked eye. Kato makita lang nato. So unsa ato makita? Makita nato tong pressure gauge, temperature gauge, ana siya. So unsa ni nga properties? we have the extensive and intensive properties. Kita ko. Lol. Okay, balik ta. So, later, we will discuss about the extensive and intensive properties. So, let's focus sa macroscopic viewpoint. So, since sa mechanical engineering, macroscopic viewpoint or approach ang kinahanglan. So, let's hear. It is the state of a thermodynamic system where it is the enumeration of all of its properties. Properties na ma-observe katong ma-count using the extensive and intensive properties. So in macroscopic thermodynamics, the properties of system are assigned to the system as a whole. Whole siya. Dili na daw ni i-discuss ingon ni sir. So how does the state of system change? So first, what is state? State is a condition of a system at a specific time defined by its properties. So unsa to siya na properties? Extensive and intensive. Ano lang to siya dire. So first, so in a thermodynamic system or in a thermodynamic interaction, so we have the system here. We have the system. System is a quantity of matter chosen for study. Then we have the system boundary. Ang system boundary is also called control surface. It is the boundary that separates the system from the surroundings. Ang surroundings naman is the area or the region that is outside of the system. And then we have the energy flow. Meron tayong energy flow sa thermodynamic system. So since thermodynamics, it is a science of energy, we understand about the flow of energy sa system and surroundings. Basic definitions. So system, kapag na ako giulit, tani maano siya ma-retain sa inyong mind. System is a quantity of matter or region in space chosen for study. So we have two kinds of system, closed system and then open system. In a closed system, there is energy flow. There is energy flow but there is no mass flow. So ang energy can be in the form of heat or can be in the form of work because oh yeah, work. And then walay mass flow. Ibig sabihin sa closed system constant ang mass sa system. No, walay mass na nagasulod, walay mass na nagagawas. Sa open system naman, we have flow of mass and also flow of energy. So both siya. Ano pod, naapoy special case na closed system. We have the isolated system. Ang isolated system kay no flow of mass and no flow of energy. So example of isolated system kay thermos. So sa thermos or mga thermal bottle, tama ba? Kay di ba walay magsulod gawas na na energy, walay magsulod na gawas na heat or work. So kung magsulod ka og tubig sa sulod sa thermos, init Japon siya all throughout, then mo to siya. Anyways, dili naman nato kayo i-topic ang isolated. Bali ano lang, ang closed system and ang open system. So we have the system and surroundings. So system and surroundings is equal to the universe. So we have the surroundings. So bali mag-ingon na lang ko daan. Wala na ako gi-change ang PPT ni sir. Ingan ni Jude ang PPT ni sir so basi ano mo na paulit-ulit siya. So we have the surroundings. Ang energy kay mag-flow lang siya inside and out of the system and the surroundings across the boundary. Ano lang, ang closed system. Energy lang, walay mass. So we have the open system, fixed space or volume. Dire, fixed ang mass, not ang energy. Dire, fixed ang space and fixed ang volume. So, later, if we say fixed ang space and fixed ang volume, kung mauna lang na ang mass na pwede mo gawas, pwede mo sulod sa system, mao lang pud na ang mass na pwede mo gawas sa system. Wala, dili na siya pwede mag-over or pwede mag-less. So, open systems have mass flow across their boundaries. So, there are interactions between system and surroundings. So, example, we have the closed system, ang surroundings, so system. Um, Another example of a closed system is example, we have a cup of water. Anyways, cup of water, imagine na lang. Cup of water. Ang cup of water na ni, is it a open system or a closed system? Open pa ni siya. We can say that kaning cup of water, open pa man ni siya, open system pa na siya. Why? Because pwede ka makadagdag or pwede ka makagawas og mass. And since, oo, ato. Once natakpan na nato na siya, takpan nato ng cup, we have it can be called now a closed system. Since constant ang mass sa sulod, dili na mo gawas ng tubig. Or even turn into vapor, dili na. Then, example, we have the energy. So, example, we have a kanik, lamig ni siya na tubig. So, 20 degrees Celsius, ang ihang lamig pa pamila. Or let's say 8 na lang, 8 degrees Celsius. Then, we have the room temperature of 30 degrees Celsius. Kapag ibutang nimo siya sa gawas, what will happen to the water? Of course, that 8 degrees Celsius will also turn into 30 degrees Celsius. So, there is transfer of heat. So we know that one principle of heat is that heat travels from higher temperatures to lower temperatures. Mm. So we have the system. If the system does work, so work is a form of energy, it releases ejected heat or ejected heat. Ana. Um, Example, naga-diet. Di ba kung naga-diet, nagahimo og work, naga-exercise. So kapag maghimo og work, ang kapag naga-diet, so naga-burn og fats, and then kapag mag-burn og fats, it will go out to the system as rejected heat. Mm. Pero ang pag-diet sa pagkabalo na ako is an open system kasi ano man na may mass na ano kasi ang naga-decrease ang mass sa system sa tao, di ba? Magpayat. So mag-decrease na yung mass. So open system siya. Ang akong ginaano lang dito is katong example sa muscle ana nag-burn. So open system, we have the surroundings, we have both mass flow and energy flow. So kaning mass matingala mo unsa ni siyang mass na ginatukoy diri, mass ni siya sa gas na naga-flow. Mass na siya sa gas. So we have the system applying power. So we know that power is the rate at which work is done, and then after na nag-produce og naghimo ang system og power, it will release heat. So there is energy flow, then again, we have the mass flow. So we have here example. Um, we have the example sa isa ka closed system. So paon sa naging closed system kaning piston and cylinder. So paon sa man. So we have here kani siya ang piston, no? Kani ang piston, kaning gimarkahan nako na mao ng piston. Then kani siya ang cylinder or ang container. Kani siyang container. And we have the gas here. Kaning piston, naga-move niyang piston. So up and down until diri. Nganong closed system man siya? We can understand na closed system siya because the gas inside the gas inside, ang mass niya kay dili mo gaw dili mo gawas or mosulod sa container. Naa lang siya sa sulod. Walay madagdag na mass, walay magawas na mass. Only energy. So, what energy ang naga-flow? Ang work. Work done by the piston. Ari, ano lang siya. Nasabtan, no? Kung unsa ning closed system sa diri sa piston and cylinder. Ana lang siya. Guys, nasabtan ang closed system. Okay, basi ingnan lang ko kung wala ninyo nasabtan. Oo. Constant lang ang mass. Wala tong tandaan kung constant ang mass. Ay, okay. Oh, ulitin na lang. So, here, now we have an example of an open system. An open system, daghan lang example. Basta tanang turbines, open system na siya. Turbines, compressors, water heater, water boiler, na open system na sila tanan. Halos. Ang car radiator, open system pod. Ang ref, it is an open system. Halos tanan man open system. Specific part lang ang closed. Ang body, ang human body kay open system. So example here, paunsa siya naging open system. We have here, kani siya is a turbine. Turbine ni siya, turbine. So if we say turbine, nagahimo na siya work. So we have fuel and airflow. So the mass of fuel and air, nagkaroon, gi-combust sila. Unsa ang product sa combusted product na gas, maadto diri sa turbine, and then after pag-adto sa turbine, it will make the compressor work. So mag-adto na dira ang gas na sa compressor. So ang compressor 'di ba mag-expand and compress, expand and compress. And kapag mag-expand and compress, magkaroon og work output diri sa isa ka shaft, diri sa pikas. So ang work energy mag-transfer dira. Then what will happen to the gas na naa diri sa what will happen to the gas na nag-transfer to katong mass diri? Of course, it will go out. So naay flow of mass and flow of energy sa isa ka gas turbine engine. O bisag water pa na siya, same lang gihapon ang mahitabo. Example, sa dam, sa isa ka dam, we have the turbine. Let's say mag-drawing tag dam. So dam na siya. So we have the water. We have the water there. Then we have ang turbine. Tama ba? Ay dili oy. Joke. Ito yung tsura sa dam. Let's say na lang ana. So we have turbine grabe. Hulog pud tanan eh. Wait, ana na lang. So mag-agi ang tubig dira. So once na mag-agi ang tubig dira, wanang dam, mag-agi ang water dira. So naay turbine diri. Ang turbine connected sa isa ka generator, then electricity. Example na lang ana. Then gawas. So mass, we have flow of mass of the water, not necessarily gas, water na pod. So pag flow sa mass sa gas, ang turbine nagkaroon og work, di ba? Nag-exert siya og work. So pag nag-exert siya og work, we know that work is a form of energy. And it was converted into electricity sa generator, then nag-produce of electricity. So, it is an open system of turbine. Ano na siya? Tapos naggawas ang water. Oh. Then, ang kaning turbine diri, naga-init po na siya. So, naa na siya cooler dira. Kasi, when there is work, also there is heat, rejected heat. Ano lang siya? Open system. Next, here. We have the control volume and the control mass. Control volume is other term for open system. And control mass is for closed system. So sa closed system nga control mass man. Control mass it's because gina-control nato ang mass sa sulod na maulang ni siya ang mass, di ba? Mawala na siyang mass, constant lang na siya. So gina-control ang mass. Wala yung mass na magawas. While sa control volume naman or the open system, we control the volume of the mass of the system na naga in and out. So ibig sabihin, example, kani piston ni siya. Ibig sabihin kung hantud dira lang na kung kani siya magtaas ni siya dira, ibig sabihin ana lang siya ang volume, control lang volume, ana lang siya. Dira og diri ang mass sa gas or sa system. So that's why control volume. So a control volume may involve fixed, moving, and real and imaginary boundaries. So we have two kinds of boundary, real and imaginary. So when we say real boundary, so katutong magunitan, katong tinuod, katong dili siya space, tong solid surface ba na kani. Ang imaginary kani tong buslot, tong hole. Muna siyang imaginary boundary. So wala, even though open space siya, but we can understand na boundary na siya sa gas. So example na ay air, volume and mass of air na mag-agi diri. So from here to here, dira nato siya ma-measure ang yang volume. So nozzle ana, lol. Okay. Then we have also tong sa sa water, tong funnel. Imagine na lang na funnel na or kanang sa oil. We have the imaginary boundary here and here. Imaginary boundary na dira ani. Then unsa ang real boundary. So mo ang real boundary. Solid surface. So dire we have also sa isa ka real boundary we have the moving and fixed. So when we say fixed, of course it will not move. Fixed lang siya. O fixed lang ni. And then we have the moving boundary, example kaning piston na. And kaning opening diri kung diri nato siya ibutang, kaning opening mao ni ang imaginary boundary. Imaginary boundary nga diri. Nasabtan lang no unsa ang difference sa real boundary, sa imaginary boundary, and sa fixed and moving boundary. Hmm. Naman siya sabton. Mga bright bitaw mo. So we have the key concepts and terms. We have the closed system. There is no mass flow but only energy flow. Then we have open system. There is both mass and energy flow. We have the system boundary, which is the boundary that separates the system and surroundings or the control surface. We have the surroundings, the area or the region outside the system. We have the universe. The universe is equal to the surroundings plus system. And then we have the thermodynamic properties and thermodynamic state, which will be tackled now. So we have the equilibrium states and properties. Equilibrium means state of balance. So, masabtan na today ang thermodynamic equilibrium. So, in a system, there we have the properties. So, to know a state of a system, we can understand it by the through its properties. So, we have the temperature, pressure, volume, internal energy, entropy, density, mass. So, mao na siya ang ginakuha na properties sa isa ka system. The system, either open man siya or closed, tanan na siya na properties ginagamit. So we have two kinds of properties, extensive properties and intensive properties. Extensive properties kay unsa? When we recall our chemistry class, extensive properties kay ang property that is dependent on the size or the mass of the system or the subject or the object. Mo nang extensive. While intensive property is independent of the size or the mass of the system. So examples extensive. When we cut half ang object, of course the mass also will cut half. Same ang volume, same sa energy. It is additive over the system. And then pero ang temperature it will not change kahit tunga pa na siya, bisag nag-upat pa na siya kabuok, same lang gyapon ang temperature, same ang pressure, same ang density. So example, seawater. Ang seawater gibutang nimo sa baso. Same lang gyapon ang iyang density with the seawater na naa sa dagat. We have the specific properties. So what are those specific properties? Specific gravity, specific volume, specific density. So tanan na sila intensive properties na siya. And they are not additive over the system. So when you say not additive over the system, kato ganina, dili siya, ano ba? Kung sa ba siya put into words? Um, wait. Basta di gina-disregard siya sa hindi man siya gina-disregard sa property. Na, okay, at any point same lang gihapon ang iyang property. Okay, wala siya di siya magdagdag, di siya magbawas, same lang ana siya. So kung additive, kung magdagdag ang mass, magdagdag pud ang ano sa ano, magdagdag ang size, magdagdag po ng mass, ang volume, energy, ana. So we have the continuum approach. What is continuum? Ang continuum approach is when we treat the system continuous as a continuous homogeneous matter. So what is the meaning of that? Um, let's say kani it is an area tapos we have the different molecules. Actually, ang continuum approach is part of macroscopic approach. So we have here a narrow road. So example, ako ni gusto na ko mag-ato diri. I will go to the other side. So, paunsa man ang ways na makaadto ko sa other side. So, kung sa isa kada kong area, di ba, pwede na ako siya lagpasan lang. Ana, pwede ko diri, pwede ko diri, 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 diri. So, dili na ako hilabtan tong naa sa tunga. Meaning, dili jud na ako ni siya hilabtan ang mga molecule sa tunga. Because since large kayo ang area sa system, or let's say kaninang system. While diri, sa microscopic approach, since wala naman tay other na agihan, agihan jud nato ni. Kana lang siya ang concept. So sa continuum approach, mao ni siya. Gina-treat lang nato ang distance sa molecules as one, ana, as gamay, as compact. Nasabtan lang ang continuum approach. Actually dili man kayo siya ingato ka big deal kay macroscopic man gihapon siya. So, next, so we have the state. The state is the condition of a system at a specific time defined by its properties. So, unsa to na properties? Tong kani. To kana. Kani. So at a given state, all the properties of the system have fixed values. So for example, we have ano, we have container 1 na properties, all properties give example. So 25 degrees Celsius. Tapos pila ang iyang mass. Iyang mass kay 10 kilograms. So example na lang ingana. So we have state 1. So ingon niya fixed values. Ibig sabihin, state 2 na siya bisan kung mag across throughout time kung same lang na siya, state 1 lang gyapon na siya. If the value of one property changes, the state changes. So if ang 25 degrees mahimo siya 30 degrees Celsius pero 10 kilograms gihapon, unsa na siya na state? State number 2. State number state number 2 na siya. Since one property ang temperature nag-change, so nag-change po ng ang state. Ano lang siya? Ano lang state? The condition of the system. Mao niya condition niya. Fixed na siya across through time. Pero since nag-change man siya, so nag-change po ng ang state. Ano lang. So if no properties are changing, then it is at equilibrium. So kung 25 degrees gyapon na siya, so equilibrium na siya. State 1 gyapon. Ano lang. So mo na siya ang sa state, equilibrium, and sa state. So equilibrium, it is the state of balance. So we have the thermodynamic equilibrium. So thermodynamics deals with equilibrium states. So for us to have a thermodynamic equilibrium sa isa ka thermodynamic system, it must satisfy the four states of equilibrium: the mechanical equilibrium, thermal equilibrium, phase equilibrium, and chemical equilibrium. There are no driving forces, or there are no forces that can make the equilibrium unbalanced or unbalanced potentials. So we have the mechanical equilibrium. So mechanical equilibrium, there is no change in pressure with time and also the weight. So example, we have typical seesaw. So we have the seesaw. We know that air has pressure, di ba? And ginasurround to sa air. So magkaroon og mechanical equilibrium if ang pressure diri sa taas with tapos na ay matter diri ay matter. Same na siya. So equal ang pressure. Wala nag-change ang pressure diri og pressure diri. So nagkaroon og balance. Nagkaroon og mechanical equilibrium. Ang ano siya? Ang mechanical na na system, mo ni siya mechanical na system. Wala siya. So nag-balance siya, nagkaroon siya og state of balance, equilibrium siya. Ana. So for thermal equilibrium, temperature is same throughout the system. So kung same ang throughout sa system, for example, we have isa ka container, naghalo ang gases na 25 degrees, 30, 32, 34, halo-halo na gases, 20, 22. So kung thermal equilibrium, what will happen to these gases? So these gases will come to a point na magkaroon sila og same temperatures tanan. So let's say ang average Anyways, wala na ako nag-calculate. Siguro mga, let's say, nahimo siya 28 degrees Celsius ang iyahang ano. So, nagkaroon na og thermal equilibrium because inside the system, ang tanan ng gases kay same na og temperature. Or for example, we have butter. So, ang butter nagikuha na to sa freezer. Ang freezer, siguro nasa 10 degrees Celsius. Pag abot sa room temperature, the butter will also become 30 degrees Celsius. So, same ang throughout niya na temperature. Ala. So, we have the phase equilibrium. We have the single phase and the two phases na equilibrium. So, sa phase equilibrium daw, no change in the amounts of different phases. So, let's say we have sa isa ka system liquid and gas. So liquid na siya, vape gas na siya. Tapos na ang piston diri napoy ana piston po dira ana mag-push. So kapag same ang amount or same ang mass sa duha, when it will come to the point na same ang mass, so naa siya phase equilibrium. Or let's say nagagawas na vapor, napoy nagagawas naay nagasulod na water, napoy nagasulod na vapor and napoy nagagawas na water. So once na mag-same lang ang mass niya sa both phases, so naa siya sa phase equilibrium. Basta same lang ang amount, same ang mass. So ano na siya, balance na siya. And then we have the chemical equilibrium. So sa isa ka chemical equilibrium, there is the chemical composition does not change with time. So, kanos ba mag-change ang isa ka chemical composition? Mag-change ang isa ka mag-change ang isa ka chemical composition if na ay chemical reaction. So, in other words, we can get chemical equilibrium if there is no chemical reaction that will happen with the thermodynamic system across through time. So, kung walay chemical reaction, what does it mean? Let's say, balik ta dito sa may siso. Tapos, kani siya, thermos ni siya. Thermos na siya na open. Or baso na siya na open. Na naiininit na tubig. Na nabutangan og ininit. Nabutangan og ininit. Naulaan og water ang metal. Bakal ni siya. What will happen to the water and metal? Magkaroon ba og chemical reaction? Wala. So, when it will stay the same H2O, tapos ang iron kay magstay gyapon og Fe. So, since kapag wala siya chemical reaction na may tabo, naa siya sa chemical equilibrium. So, example kani isa ni siya ka thermodynamic system na ay mechanical equilibrium, tapos kani siya ang tubig diri, thermal equilibrium. We have the phase equilibrium na ay pressure then water here, gas, water, then pressure here, the gas pressure. Then we have the chemical equilibrium. Ana. We can call it a thermodynamic system pag na-satisfy niya ang upat. Nasabtan lang ang sa equilibrium sa thermodynamic system. Okay. So I hope nasabtan jud ninyo ha kay magpa-quiz ba si Sir. Dili ako ha. Si Sir jud na Sir Ronald na objective type siguro. I don't know kung kano sa. Ah, ah, ano? Oo, naka-screen record. Screen record ni siya. Okay, post ko lang ni siya sa YouTube. So, lastly, we have ano sa to? Nay gusto ingon? Wala na. Okay, we have the last, the state postulate. So, if we say postulate, so rule. So, theorem, kumbaga, sa ano. So, sa state postulate, the state of a simple compressible system is completely specified by two independent intensive properties. So, what is that simple compressible system? Ka-jargon ba, oy? Simple compressible system is also called single phase system. So if we say single phase system, what is an example of a single phase system? Air pump. O air pump, air pump. Air lang man ang yang ginaano, gina-compress and ano, ra, air pump. So independent intensive properties. So for example, we have the system na container. So we have the system or the container. Let's say na siya'y gas sa sulod, which is nitrogen. So we have the temperature, let's say 28 o 25 degrees na lang hangapon. 25 degrees Celsius. Then we have the specific volume na 0.9 kilogram ito, kilogram, tama ba? Ano ba ang ano sa volume? Specific volume. Wait, na-exit. Okay. So, we have the specific volume. Wait lang. Ay, di siya maka-rejoin. Wait. Kung sa ano ni? Ano? Sulod lang balik. So, wait lang, balik ko. So, we have the specific volume, which is 0.9 meter cube, meter cube per kilogram. So, unsa ning ginamin sa ano sa completely specified by two independent intensive properties. So, what are intensive properties kani? Temperature, pressure, density, and specific properties. So, specific volume, specific density, specific gravity. So, we have here temperature and specific volume. So, ang isa ka state niya, kumbaga, pwede nimo ma-solve ang pressure, pwede nimo ma-solve ang internal energy, ang entropy, and unsa pa dira na mga kailangan i-solve sa isa ka problem using only these two, temperature and specific volume. So mao na siya ang sa state postulate, na magamit lang nimo ning duha lang jud na ano na properties to solve the rest of the properties. So in a simple compressible system, gina-disregard ang electrical, magnetic, gravitational, motion, surface tension effects, or the external forces na electrical, magnetic, gravitational. And then independent ang isa ka single compressible system or isa ka state if one property can be held constant while another is varied. So pag matawag siya na independent ang state kani kapag ang temperature mas ma-change siya pero constant ang iyang specific volume or vice versa. So ana siyang state postulate. And here we end our discussion and klase for for thermodynamics. So any question, guys? Oo. Ay none? So sure. Sure, walay question, walay bisag unsa na mga question, wala mo nasabtan, wala mo wala mo nasabtan. Nan po. Ay, okay. Naamoy schedule tanan sa MTH na 10:30 to 12? Wala. Ay naa ang uban? MTH 10:30 to 12. Bali, pero tanan na second year. Second year katong karon na batch na MTH. Wala. Kay ang balak nako manggod, nasabay na lang, ito man, thermo man ni. Sabay na lang tanan.